Okay, so it's graphing quadratics in vertex form. We've been doing it in standard form. I actually like vertex form. If I have to graph a random parabola, I'm more likely to put it into vertex form and graph it than I am to actually do standard form, because vertex form is just easier to work with. So Roman numeral 1, let's start out with what the heck is vertex form. Okay, vertex form is y equals a times x minus h quantity squared plus k, which is really similar to vertex form for absolute value graph. It's practically identical. All right, so what makes it vertex form? It means that the vertex is right there in front of you. You don't have to calculate it. The h is the x coordinate. You have to watch it though, because it's x minus h, so the h will change sign. And then k is what you see. What you see is what you get. Now, the other things that you've learned about parabolas are still true. If you have a positive a, it opens up, except this time the a is sitting in front of parentheses. A negative a means it opens down. If the a is plus or minus 1, it has a medium bell. If a is less than 1, a positive or negative fraction, then it has a wide bell. And if a is greater than 1, it's 2, 3, -2, -3, you're going to have a more narrow bell that you're looking at. Okay, so let's do an example. We're going to start just by looking at a vertex form equation and identifying pieces of it. So f of x equals a negative times x minus 1 squared plus 3. All right, easiest thing to get off vertex form is the vertex. So the h is the x coordinate. Remember, it's the opposite sign. So it's a positive 1, comma, the k, it's plus k. So what you see is what you get. It's a positive 3. Now, in this case, my a value here is a negative 1. So this one opens down. And the a is a negative 1. So it's going to have a medium bell. So if we do a little sketchy thing over here, we've got a parabola opening downward with a medium bell and a vertex at 1, 3. Even from just a small sketch, you can figure out the axis of symmetry because it shares the x coordinate. So your axis of symmetry is x equals 1. And again, that's related to the 1 on the vertex. And if we wanted to do a maximum minimum statement, we would say that this graph has a maximum of the tallest y value, so y equals 3, and this occurs at x equals 1. Okay, so let's do another one. So that one's just like basically how to read it. Any questions about how to read the formula? Okay, let's do another example. Let's say that you have an equation in standard form. Y equals x squared minus 6x plus 6. And we're going to change it from standard form to vertex form. So to do this, you need to complete the square. All right, so for completing the square, we're going to have x's on the right, non-x's on the left. So we're going to subtract 6 over to the left. So y minus 6, leave a space, equals x squared minus 6x, leave a space. The only difference from what we've done is you have a y parked over there along with your number. Okay, magic formula time. We're going to do b divided by 2 quantity squared. My b value is negative 6. So negative 6 divided by 2 squared is negative 3 squared, or positive 9. So we're going to add 9 on the left add 9 on the right. So on the right-hand side, we can now factor this into a perfect square, x minus 3 squared. On the left, 9 minus 6 is 3. So the last thing you need to do is subtract 3 over to the right, and you get y equals x minus 3 squared minus 3. All right, so let's say that you need to find the x-intercepts of the graph, which means you're going to set y equal to 0 and solve. Really, I think you could figure this one out, but I was going to show it to you anyway because it looks a little weird. So 0 equals x minus 3 squared minus 3. So you need to get the perfect square alone. Now, if you subtract the perfect square to the left, you now have a negative scalar to deal with. So it's easier if you just add 3 over to the left, and that gives you 3 equals x minus 3 squared. You can still solve with x on the right. So once you get the x minus 3 by itself, you're going to do what you did on the homework, square root both sides. This will split your answer into, and I'll go ahead and reverse it now, positive x minus 3 equals radical 3, and negative x minus 3 equals radical 3. So on the left, the positive distributes and it doesn't change anything, so we're just going to add 3. And we get x equals 3 plus radical 3. Remember, the rational part comes first, irrational part comes second. So on the right, we're going to divide by a negative 1. That gives us x minus 3 equals negative radical 3. And when we add 3 over to the right, we end up with x equals 3 minus radical 3. So our intercepts are 3 plus and minus radical 3, comma, 0. So really, it's actually easier to find the x-intercepts because you already have a perfect square set up. You don't have to do the perfect square. It's already right there for you.
So there was a positive, we saw it to the other side.
There was a positive what?
Positive 3. There was a positive.
You would still subtract it and you would end up with an imaginary answer. All right, Roman numeral 2. All right, we are going to graph in vertex form. And the example we're going to start with is f of x equals negative 1/2 x squared minus 2x minus 3. So the first thing we're going to do is change it from standard form to vertex form. So we're going to complete the square. Add or subtract x's to the right, add or subtract numbers left. So we're going to add 3. Now, at this point, if you want to change the f of x to y, because it's just cleaner, you can do that. So I have y plus 3, leave a space, equals negative 1/2 x squared minus 2x, leave a space. Okay, on this one, I do have a scalar on the front of my x squared. So remember, if your scalar is a fraction, you get rid of it by multiplying by the reciprocal. So I'm going to multiply by 2 over negative 1 for both terms. The negative 1/2 that I'm dividing off goes to the front, and I'm left with x, and then negative times a negative is a positive, so plus x squared plus 4x. All right, now we use our magic formula. My new b is 4. So we're going to do b divided by 2 quantity squared. So 4 divided by 2 is 2, and 2 squared is 4. So I'm going to add 4 inside the parentheses. And then to balance it, I'm actually adding 4 times negative 1/2, which is a negative 2. So a negative 2 has to go on the left. So the left equals the right. All right, 3 minus 2 is 1. So now I have y plus 1. And then I've got a negative 1/2 scalar. This factors into x plus 2 squared. And the last thing you need to do is subtract the 1 over to the right. So y equals negative 1/2 times x plus 2 squared minus 1. That's probably the most complicated one you're going to run into. All right, so the bonus of all that work is not only do we have a lovely perfect square for x-intercepts, we have the vertex without any more work. So your vertex is the x-coordinate is -2, remember opposite sign. The y-coordinate is -1, same sign. My a value is negative, so it's going to open down. And my a value is a fraction, so it's going to have a wide bell. Okay, so we're going to draw our graph. And we need to accommodate some width here because it is a 1/2. So you're going to get a wider bell than what you're used to seeing. And I'm going to go ahead and box off my laundry list here. So -2, -1, there's my vertex. I'm going to put my axis of symmetry right down the middle. My axis of symmetry, remember it shares the x-coordinate, so it's x equals -2. Now, since this is the vertex below the x-axis and it's opening downward, how many x-intercepts is this going to have? I have 1 vote for 1. I have 1 vote for none. What about the rest of you?
I say none.
You say none? If you're thinking none, you have it, because if it's opening downward, it's never going to cross, which just means that when we get the x-intercepts, they're going to be imaginary because it's not going to have them. Okay. So let's go over here. So we have domain, we have range. We'll save those for last. We're going to do a max-min statement. In this case, it's a maximum. And we're going to do x-intercepts. All right. What time is it? Okay. So we need a couple points. We already know that our x-intercepts are not going to give us any bonus points because it's going to be imaginary. We still have to find it, but it's not going to help us get points. Okay, so when you pick your x's, pick them mirrored. So 1 to the right is -1. 1 to the left is -3. Those two should have the same y. 2 to the right is 0. 2 to the left is -4. Those should also have the same y value. So we're going to sub these in and hope we get whole numbers. So put a -1 into the equation. You get -1/2 times -1 plus 2 squared minus 1. Now remember, you have to do the perfect square first before you multiply by -1/2. So 2 minus 1 is 1. 1 squared is 1. So I have -1/2 times 1 minus 1. Yeah, so that was not going to give me a good point. That's going to give me -3/2. So that's actually not usable. So if that one's not usable, that one's not usable. So I got to go different points. So I think I'm going to go further out. I know that I have a 1/2 fraction, so I want my x to be divisible by 2. So I think I'm going to do, instead of those, I'm going to do 2 and 6. As my other pair. I think I'm fine with 0, -4 because those are both even numbers and the 1/2 should divide out. But let's try it. Let's try the 0. -1/2 times 0 plus 2 squared minus 1. 0 plus 2 is 2. 2 squared is 4. So I have -1/2 times 4 minus 1. -4 divided by 2 is -2. Minus 1 is -3. Ding, ding. We got a good one. Okay, for time, I'm not going to do the -4. It should also, though, be a -3 because those are mirrored points. Okay, let's try the 2. So I've got -1/2 times 2 plus 2 squared minus 1. 2 plus 2 is 4. 4 squared is 16. So I have -1/2 times 16 minus 1. Half of 16 is 8. So I have -8 minus 1, which is -9. I got a nice whole number. So the 6 is also going to be a -9. All right, let's plot those. So we have a 0, 1, 2, 3, and it's kind of fat looking, which is what we expected. 1, 2, 3, 4, 1, 2, 3, -4, -3, 2, -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 6, -9. Let's see. 1, 2, 3, 4, 1, 2, 3, 4. Draw your curve. So I didn't know that was going to come up to be a fraction. I honestly didn't. You just have to try it and see. And if your point doesn't give you a whole number, try a different one. Every once in a while, you'll have like a fractional vertex and whole numbers won't be possible. But most of these are been carefully manipulated so that they will work out. All right, so let's really quick do the laundry list. Your domain, infinitely left, so -infinity, infinitely right to +infinity. My range goes infinitely from the bottom, and the maximum y value is -1. It gets a bracket because that's on the graph. This is going to be a maximum, so I have a maximum of y equals -1 at x equals -2. If it's opening upward, it will be a minimum, but this one's opening down, so it's a maximum. Now, again, I don't have time to go over how to do the x-intercepts, but if you want to use this as a practice problem, the x-intercepts end up being -2 plus and minus radical 2i, comma 0, because there basically are none. They come out imaginary. All right, that is the end of the notes. I hope that was helpful.